This video will discuss how to create a mean control chart in Excel. The example here has 40 samples of the weights of 10 bags of concrete mix. You can see the weights are measured and listed by sample on each row. The samples represent 5 days of an 8-hour shift each day. As you can see, the mean control chart will be for variables that can be measured on a continuous scale, such as weight and volume, or time. The first step to create a mean control chart will be to calculate the sample range for each sample. The sample range is used for the case where the process standard deviation is unknown. The sample range is equal to the maximum value in each sample minus the minimum value in each sample. Once we've entered the maximum minus the minimum on the first row, we can copy it down to all 40 samples. The next step in constructing the mean control chart is to simply calculate the sample mean or average for each sample. Be sure to notice in this data there are 10 sample observations per sample, so the sample size is 10. The next step to constructing the mean control chart will be to find the average range and the average sample mean. We need the average for both of these values. We can simply use the average formula to find the average of the ranges. And again, to find the average of the sample means, sometimes called the average of the averages. Oftentimes these quantities will be called R bar with a capital R and X double bar. The next step to constructing the mean control chart is to look up the constant value, A2, that's used to calculate the control limits. A2 is based on the sample size, and in this case the sample size is 10. A2 is listed in the chart of factors for computing control chart limits in the Operations Management textbook. In the case where n equals 10, the value for A2 is 0.308. Now we need to calculate columns for the lower control limit, denoted by LCL, and the upper control limit, denoted by UCL. The lower control limit is going to be the center of the chart, which will be the X double bar value, minus the A2 value, times R bar, which is the average range. In this case, all of these have absolute references. What we're going to do is copy the lower control limit and upper control limit all the way down the worksheet, because this will simplify creating a control chart in Excel. The upper control limit is very similar. It's X double bar, but plus A2 times R bar. So again, we just copy that all the way down the chart, and this will just basically allow Excel to create a straight line for the control limits. The other value that we want to place on the chart is the center line of the chart, and the center line of the chart is simply X double bar. We enter this with an absolute reference, and then copy it all the way down the chart. Once we have these columns calculated, creating the control chart in Excel is simple. These are the 4 series that we want to have on the chart. 3 of them will simply appear as straight lines, where the sample mean will fluctuate over time. It's important on the mean control chart, or any control chart, that we maintain the time ordering of the data. Day 1 to 5 here, and hour 1 to 8 for each day. Once the data is highlighted with the column labels, we simply go to the Insert menu, and then select the Insert Line Chart option. And typically, the second option down on the left works the best. This gives us our control chart. I'm going to click in the title and just change the name. The control chart will be a little bit easier to view if we view it in a separate tab. You right-click in the white space at the top, select Move Chart, and then put it in a new sheet. The chart will be easier to view. In this case, we see that the lower control limit is the orange line, the upper control limit is the gray line, and the center line is yellow. The sample means for each hour vary, obviously, with each hour on the chart. The first thing that we look for is to see if any points are outside the control limits. This would indicate a point in time where the process was not centered consistently. In this case, we don't see any points outside the control limits. There are some other runs tests that we will learn in order to evaluate control on charts, but there doesn't look like there's any immediate concern to investigate the points that are outside the control limit for this process.